All right, people, what's happening? Hey, hope you're doing great. Welcome to the start of chapter 3. So let's take it away. Guys, we got all kinds of new words here. We're going to get into linear functions this time around. So we're still going to be working a little bit with equations. We're going to be doing some stuff with graphing now. So let's kind of familiarize ourselves with some new words that we got going on today. So first and foremost, guys, the linear equation. When we think of these, right, especially when we think of them on a graph, they're going to make a straight line. So I'll just put on here, they form a straight line when graphed. Okay? What does that look like? Well, we've seen these before, right? When we were doing domain and range, we've seen some of these before. So here we go. They might look something like that. You know what I mean? That could be an example, right? We could also maybe have one that's going the other way, kind of going downhill. Okay? Those are both linear equations or linear functions, we'll say. Standard form. Standard form looks weird. It looks like this. AX plus BY equals C. Okay? Things to note here. A and B, those are just the coefficients of my two variables, X and Y. All right, C is what we call this word right here. C is our constant. Okay, so if we have some numbers in here, right, those are my constants, right? We're always, adding this number or subtracting this number. Okay, so C is just a constant. Bam, right? And we'll see that once we get into some of these functions and equations and kind of what they look like. X and Y intercept, should be familiar with these already, right, from doing some of our graph stuff where we were talking about maximums and minimum values and where things cross the X and Y axis. So those ones shouldn't be new, so we're not going to spend too much time on them right now. Let's dive right into the rest of this, guys. Okay? We got a lot going on today. A lot going on. So here we go. So here's that standard form again, right? AX plus BY equals C. Again, X and Y are isolated on one side of our equation. Our constants are on the other side. Okay? You like to call them numbers a lot of times. Okay? So in here they've given us an example of 3x plus 2y equals 5. And then they went ahead and went through and said, okay, hey, 3x, well, there's your x variable 3, right? If we did some matching up, would match up with a because that's your coefficient, so on and so forth. Some good reading material there for you folks. Have at it if you like to. Okay. So, all right, so here we go. So we've got to determine whether this 5x plus 3 equals xy plus 2 is a linear equation. Well, how are we going to do that? Well, for starters, I would say let's put it into standard form. Again, standard form. X and y are on the same side of the equation, right? Numbers are on the other side. So I'm going to go ahead and we're going to say, well, here, I'm going to write it here. 5x plus 3 equals xy plus 2. All right, so I'm going to move that 3 over there with the 2. We're going to do that with a little bit of subtraction. So I'm going to be left with 5x equals xy. We're going to subtract 3. 2 minus 3. Somebody said it out there, negative 1. Probably Natalie. She is a subtraction guru. All right, let's bring this other variable over here, right, this xy. So again, I'm going to subtract that over here. So it's going to look like this. 5x minus xy equals negative 1. Is this a linear equation? Is this a linear equation? Everybody lock in your guesses for yes or no. Okay, this one's a sneaky one. I love how we start off with a sneaky one. All right, so right here, guys, this term, right? We've got 5x, boom, that looks great. xy, right? There's two variables on one term. If you want to be a linear equation, you can't do that, okay? So because of this right here, not a linear equation. Everything else looks great. 5x looks good, equals negative 1 is fine. But when we have two different variables, in this case x and y, tied to one term, you can't be linear. You can still be a function and all these other things, but for our case today, you are not a linear equation. Okay? Here we go. We're going to do the same thing with this one right here. Again, determine whether or not 3/4 x equals y plus 8. So again, I want to move my two variables together on one side. I want my numbers on the other side. So 3/4 is already in a good spot, right? All all we really need to do, guys, is move y over here, okay? This is why we worked on 2-7, those literal equations, so much, right? Because I don't want to change anything. I just want to rearrange this stuff. So let's move y over here. That's right. We're going to subtract it. So it's literally just going to look like 3/4 x minus y equals that positive 8. Now, is this a linear equation? Sure it is, right? We've just written it in standard form. X and y are the only two things on the left-hand side. My number is the only thing on the right-hand side, right? And we're good right here, okay? Great. Is this one a linear equation? Okay? So once again, y equals 4x minus 5. Remember, my standard form, ax plus by equals c, right? It likes to have the x variable first, followed by y. Again, it's doing that in alphabetical order, and that's fine. We can move 4x over here. When I do that, I'm going to put it in front of. Once again, it's not going to combine with y. I'm going to move it in front of that. So we're going to subtract 4x from both sides. Again, the 4x and the y do not combine with each other, right? They're not like terms. They don't get to combine with each other. All I'm left with is this stuff right here. Negative 4x plus y equals 5. Is this one in standard form? Yes, it is, right? X and y are together on the same side. Is this one a linear equation? Yes, it is as well, right? 4x, y, just one variable in each one of those terms, so we're good to go. All right, here we go. Right, I'd like to know if this one is a linear equation. So 8y minus xy equals 7, right? It's kind of in that ax plus by equals c, right? This is my standard form, right? We just talked about this at the beginning, right? This is what standard form looks like. So one variable plus another variable equals our constants. Is that what's going on here? I got one variable, I'm subtracting. Okay, no big deal there, right? We got a constant over here. Here's the problem, guys, right here. Again, it's that same thing. We've got one term, but we have two variables with that one term. So, can't be a linear equation for that to happen, right? This can't be x, y. We could get rid of that y and just make this 8y minus x, and now we're getting somewhere. But as it is, can't do it, all right? Okay, you guys doing good? Any questions yet? Nothing. You guys are quiet today. All right, onward we go. Okay, might need to back this one down a little bit. Find the x and y intercepts of this graph, okay? Okay, so again, this shouldn't be anything new. We should be able to roll through this really quickly, guys. Here it is. Here's my y-intercept. There's my x-intercept. All right? If we want to identify that, that's fine. We can do that with an ordered pair. This is at 0, 200. Okay? We can identify the x-intercept. Again, by ordered pair. It's all the way down there at 4. This is going to be 4, 0. Again, thing to notice here, right? Think about this. When we find the y-intercept, right, what if we didn't have a graph? Could we still find it? Like maybe if they just gave me a whole bunch of ordered pairs, could we pick it out? Well, sure we could. Look what happens. When we're looking for our y-intercept, guys, we're looking for a y-intercept that has a number, and our x value is 0, because that means it's going to find itself somewhere on that y-axis. Okay? The same thing is true when we're looking, right? Again, maybe, I don't know, just some foreshadowing here, we'll see some tables, and we'll have to figure out an x or a y-intercept. So look back here. When my x-intercept, right, is a number, right, we know y has to be 0, because that won't move it up or down. That'll just be whatever number it is on the x-axis. Okay? So we'll do a little bit of that, I'm assuming, here pretty soon. But for the meantime, there's that one. Okay, we're about halfway through. We're making some good speed here. Find the x and y intercepts of this one. If you guys want to pause this and try it, go right ahead. If you don't, that's all right too. I'm going to say our y-intercept is right here at this number. That appears to be the number 250. Okay. Our x-intercept, this is at that number all the way over there, 10. Again, there you go. Stay with me, magic marker. 10, 0. Okay. Nothing fancy about this. pretty straightforward, identifying intercepts from a graph. All right. Oh boy, word problems. You know we're getting close when you see the word problems, guys. Okay, here's what we got. It says a box of peanuts is poured into bags at a rate of 4 ounces per second. The table, there it is, all right, shows the function relating to the weight of the peanuts in the box, right, and the time in seconds. So again, as time increases, what's happening to the weight, right, of the peanuts, right? Again, it says a box of peanuts is poured into bags. Okay. Yes, do we have a question in here somewhere? Ah, yes, here we go. Okay. Can we find the intercepts, right, from this table? This is what I was just talking about a second ago. So guys, if you look here, again, we know, and they've already done it for us, right? They told us which one is X and which one is Y. We didn't have to figure that out. Yes, I love when they do all the hard work for me, okay? All we have to do is look here and figure out, okay, right, what are these ordered pairs? Which ones are the special ones? So once again, right, we're looking for those zeros, right? We know if you're an intercept, your X or your Y value has to be 0, right? So if I'm thinking about this first, right, here, let me make that super big, right? Again, this is one of my ordered pairs right here. This, comma, this. Again, I recognize the other one down here is a 0. Here's my other ordered pair. So who's who? Who is the X-intercept? Who is the Y-intercept, right? Well, right here, when your X is 0 and your Y is that number 2,000, right? That is your Y-intercept. Okay? When X is a number, but Y is 0, if I can say it, that's your X-intercept. Okay? So here's my X-intercept at this 500, comma, 0. Okay. Good so far. So we should be able, guys, to find intercepts from a table, like here, from a graph. Okay, that's the easier version. Either way, I should be good. Okay? All right. Here's a table right here. Again, you can read through this problem. We're talking about Jules. He's got a gas card. The table shows the function relating the amount of money on that gas card and the number of times he's purchased gas. So we can all envision what this looks like. You know, here it is. You just got your driver's license here in a few years. You know, grandma, grandpa, whoever, crazy aunt gives you a gift card for the gas station. It's got $100 on it. You're like, man, yes, I can drive forever on $100 worth of gas, right? So it's got $100. Like, what's the starting quantity or starting value? What's that $100? Well, let's say you fill up one time. It doesn't have $100 on it. Now it's got some amount less. Then you fill up again. Now it's got a little bit less, right? And that pattern continues until, unfortunately, you're out of it, right? That's what this table shows right here. So number of gas stops, so we haven't stopped for any gas yet. 0 stops. We still have $125 there. At 1 stop, now we're down to 100. At 2 stops, now we're down to 75. So on and so on. Part A says determine the X and Y intercepts. Again, if you want to try this on your own, go ahead, pause it, come back. Okay, hopefully you're back. X-intercept, guys. X-intercept is right here, 5, comma 0. My Y-intercept is up here, right, at 0, comma 125. Describe what the Y-intercept of 125 means. That's part B of this question. Okay. What does 125 represent? Well, it represents the amount of money. What does 0 represent? This. So try to use the 2 variables and the 2 numbers in a sentence. Okay? I don't really care which one you talk about first, right? Here's what I would say. Right? That means when we've stopped for gas 0 times, right, we still have $125, right, on our gas card. That's what it means, okay? So in this case, the Y-intercept is just how much money we started out with. Okay? Here we go. Graph 4x minus y using the x-intercept and the y-intercept. Okay. So we're going to get into graphing, guys. I'm going to show you Just how to hand graph these super quick. Because think about it, right? If it's linear, guys, it's just going to make a straight line, right? It's just going to be a straight line. How many points do I need to make a straight line? 24, 21, 23? No, you just need 2, right? Because if you have 2 points here and here, there's only one possible straight line we can draw through them, right? Well, we can do that if we know the intercepts. And it's super quick to figure out sometimes, okay? So if you want to find the intercepts, guys, here we go. Let me be a marker. 4x minus y equals 4. If I want to find the x-intercept, right? If I want to find that, all I need to do, throw a 0 in there and see what we get, okay? So if I replace this x with 0, and I leave everything else just like it is, guys, solve this equation for y. That's all you have to do. Okay? So what's 4 times 0? Well, that's just 0. Minus y equals 4. Well, this pretty much goes away because it's nothing. So you've got negative y equals 4, or in this case, y equals negative 4. Okay? Make an ordered pair out of those two numbers. So this is 0, negative 4. So in other words, when x is 0, y is negative 4. Is that an intercept? Yeah, it is, right? So if we want to find our y-intercept, we just make x 0. Right? Replace x with that number, and then solve our equation for the other variable. Do you think it would work the same way for the y-intercept? I'm sorry, the x-intercept. We just did the y-intercept. Absolutely, guys. Okay? So it's going to look just like this. We're still keeping that same function. Right? 4x minus y equals 4. Okay? Instead of replacing x with 0, now we're going to replace y with 0. So 4x minus 0 equals 4. Again, this goes away. 4x equals 4. Solving for x, I get 1. Write your ordered pair. When x is 1, y is 0. Okay? Can I graph this now? Yes, I can. I need to make some room here, so let me get rid of all this. All right? But those guys, those are your 2 points you can use. Make all this go away super quick. Okay? All right, so here's my graph. We can just approximate where these 2 points are. So 0, negative 4, right? 1, 2, 3. So I'll say 0, negative 4 right here. 1, comma 0. Again, going to be like, hey, here's 1. Bam. So there's my 2 points. Draw a line between them. Awesome. Good to go. All done. Okay? So that's how I can easily find the intercepts. And once I have them, boom, draw my line. I don't have to do any more work than that. Right? I know that line looks like it's going uphill. Kind of steep to me. Okay? Stay with me, folks. A couple more. Is this the correct graph for this? Well, can you identify these 2 intercepts for me, guys? Yes, we could, right? Here's 1. Here's 1. All right, so this is at 0, 2. This is at 1, 2, 3, 4. This is at 5, 0. Well, let's repeat the process of what I just did a second ago and see what happens for our x and y intercepts, okay? So 2x plus 5y equals 10. If I want to figure out what my x-intercept is, make y 0. So 2x plus 5 times 0. This always happens, guys. This always cancels out and goes away and turns into nothing. Right? 5 times 0 is 0, so it pretty much has gone away. So I'm left with 2x equals 10, or x equals 5. So once again, when x is 5, y is 0. Again, that's why I replace it with 0. Does this match up on our graph? It does, right? So this point checks out. Good to go. What about this one? Well, let's repeat the process and see if it works out. Look, here, I'm just going to come back to the magic. So here we are. Bloop. All right. This time, instead of replacing y with 0, now I replace x. So now it's 2 times 0 plus 5y equals 10. Right? Or in other words, hey, 0 plus 5y equals 10. Well, again, this always happens. This value cancels out, turns into nothing. We're left with 5y equals 10. So y is 2. There's your y-intercept at 2, right? Again, we plugged a 0 in for x. We got 2 as a y value. 0, comma 2 there. So is this the graph? Sure it is, right? We proved it with intercepts. We found both of them. They matched up with 2 and 5. Good to go. All right. Oh boy, a little too big there. All right, this one says graph this, then state the domain and range. Okay. Due to time constraints, we're going to fast forward. And look, like magic, guys, I have graphed this. Bam, there it is. Okay? So here it is. Here's the graph, right, of 2x plus 2, right? Is it a linear equation? Yes, it is, right? It makes a straight line on that graph. What is its domain and range, right? So in other words, how far to the left is it going? How far to the right is it going? That's my domain. Range, up and down. How low does it go? How high does it go? Okay? Well, we can keep, I can hit the zoom out button and we can zoom out and zoom out and zoom out. This function, this graph right here, not going to change. It's just going to be a straight line that goes on in those two directions forever. Okay? So if we're thinking about domain and range, again, here's our graph that we just saw. Right? It looks just like this. Right? So what is my domain? Right? Our domain isn't darn. Darn the bad luck. Nope, it's all real numbers. Right? Other ways we could write that. X, bam. Okay? Compound inequality. Another way we could write it with those weird parentheses or brackets or whatever, right? Interval notation. You can just put, hey, we're not including that, right? Because we can never really include infinity, right? Only Buzz Lightyear can do that. Okay, so we're not including either one of those numbers. That's why they're just parentheses. That's why we were just less thans up here, right? We can't include that number, but every number up to that one we will. Okay, range, guys, is going to be exactly the same, except we're talking about y values. So it's going to be all real numbers. It's going to be negative infinities that are less than y, that are less than positive infinities. In interval notation, it will look just like that as well. Because again, there are no numbers, right, that this will not include. And last but not least, is this the correct graph for this? I don't know. I'm thinking maybe I could do intercepts like I did last time. But I don't really know what number this is. You know what I mean? Like, do you guys know what number that is? Right? Like, look, it doesn't, here's -1, here's -2. So it's a number somewhere between -1 and -2. I don't really know what it is. Okay? Here's another way that we can do this. Okay? If we pick some ordered pairs that are on this line, right? So in other words, if we pick this point right here, this is the y-intercept. This is at 0, -4. If I pick this point over here, this is at -1, -1. If I pick those 2 points, and again, I could pick a whole bunch of them. When we take those values and we replace them with x and y in here, we should get true statements, right? True mathematical sentences, okay? So let's see how this works. So let's try this y-intercept first of 0, -4. So y equals 3x minus 4. So again, everywhere I see a y, I'm going to replace it with that -4. Here's my 0, that's an x. I'm going to replace it here and then see what happens. Okay? So y is -4. Does that equal 3 times x minus 4? I'm not sure, right? But we're going to keep going here. So -4 equals 0 minus 4. Okay, now this is starting to make sense, guys. What's 0 minus 4? That's right. Natalie's all over this one. -4. Is this a true mathematical sentence? Absolutely. So this point checks out, right? This ordered pair is definitely in that graph or on that graph. but we have to check more than one point. We need to check other ones as well. So let's do the -1 point, right? I'm a little bit skeptical. I don't really know if it's going to work or not, but we're going to check it out. So again, x and y are both going to get replaced with those numbers from that ordered pair, -1. Then one of two things happens. We get a true sentence or we get a false sentence. If it's true, then that means, yes, this ordered pair, right, should match up and be on that one. If not, well, who knows? So y is -1, x is also -1. Okay? 3 times what here? -1 equals, this should be -3 minus 4. -3 minus 4. Good job, Kendrick. -7. Is this a true sentence? Does -1 equal -7? Not in my world. That means, guys, that this ordered pair cannot match up with this. So this linear function is not this one. Other ways that we could have done this, and we'll get into that, but I want to show this because this is probably one of the single most confusing things that kids don't understand, is that, hey, if this function matches up, then all of these ordered pairs should fall on this line perfectly, right? And in this case, we found one that did, but we also found one that didn't, okay? So anyway, with that, guys, that's the end of 3-1. I hope you guys had fun. We're going to get into all of our other magical stuff that we do. So our quizzes, our book work, and unfortunately our homework. So hope you guys are having a great day, and I'll see you soon.